You know, there's some pretty ugly geometric proofs and algebra and ugly calculus and using limits and replacements and trigonometric rules to find the derivative of sine and cosine. But I'm going to show you the way I show it to myself if I ever need a reminder. Okay, let's say I have a triangle. Well, I just can't get it to go the other way, can I? Let's say I go like this. Maybe I can flip it like this. Oh, snap. Okay, we'll use this. Let's say I have a triangle and I take something like this. Okay, I'm going to give it an angle. I'm going to call it H just for the heck of it. Right? And this here, well, this is an X value. And this here, this is a Y value. Would you agree with that? Just so our X and Y axes, right? I'm going to take these away just to keep it clean. Now, that means this point here is the point cosine H sine H. Yeah? Yeah. Remember your SOHCAHTOA that you thought you'd never use that again. So sine, that means sine of H is equal to opposite over hypotenuse. And on a unit circle, the hypotenuse is always length 1, and the opposite is opposite the angle, so that's this height. So that's the y coordinate divided by 1. And that's how we end up with this, because of course cosine is going to be the same way. Adjacent divided by 1 gives me just the x value. So cosine H sine H, that's what I like to look at here. Let me just clean this up some more, because we don't really need a lot more than that. Because that means that the sine of the angle is the y coordinate. And that's what I want to look at over here. So I'm going to put sine of H. Notice I'm not using an x here because I don't want to confuse you. X is a coordinate, and we're using an angle for our input to sine to get our y value. And we'll be using H as an input for our cosine as well for our adjacent, which is going to give us the x value. So we could say x equals cosine of H. Okay, so you have to kind of be careful with what you want to use for your inputs. Okay, so 0 degrees always starts, I'll use something obvious like this red. We always start here at 1, 0, and with sine as the y coordinate, that means sine starts at 0. And at 45, it's root 2 over 2, and at 90 degrees, or pi over 2, if you want to call it that, it's 1. So if I have 1 and minus 1, it goes like this. As you well know by now, because you've taken trigonometry, right? So the next time it's 0 is when the y value is 0. Well, that's not here, it's here at 180 degrees or at pi, right? So here's pi, here's 0, here's 2 pi. Okay, and for cosine, it actually starts up here at 1, doesn't it? The x coordinate here is 1. So cosine is 1. And then what's happening, the x coordinate here is reducing because now it's at 0, and then it's at a negative value over here all the way to negative 1. So we're going to find that cosine goes to negative 1 like this. And maybe the phases aren't perfect because I'm not a great artist. But here is when x is 0, so that's pi over 2. And here's negative 1, so that's pi there. And then 3 pi over 2, and then at 2 pi, you're back at the beginning, so we're here again. Okay, so something like that. It's not perfect, you know, vertically, but whatever. Let's look at something here. Let's just keep it easy, because what I want to find is not exactly a refresher on trigonometry. I want to use it for a reason. I want to find the derivative, and I'm going to call it, you know, d dx of sine of x, like this. Just because we use a classic formula, right? But since we don't want to confuse our x and y coordinates, I'm going to write like this, d dh of sine of h. That is to say, we take the derivative with respect to the angle, whatever symbol we use for the angle, and we need to find what it is. So let's look at the graph of sine over here. And when I look at this, let's just figure out where it's 0 first, right? So it's here. That's pi over 2, right? And it's 0 here, which is at 3 pi over 2. So if I'm going to make a graph, let's clean this out of the way too. If I'm going to make a graph of the derivative of sine of h, I can just kind of walk through it like a putz and see if I can get there. So let's try and keep it straight here, like that. I like that better. And we'll do something like this. Maybe a little wider. Okay, good enough. Next, we know at pi over 2 and at pi, 3 pi over 2, 2 pi, we know it's 0. I'll use gold this time. We know it's 0 here. Okay. Where else do we know? Well, I have a hankering that this is about -1, and this is about +1. If you look at the actual graph, it'll be more obvious, but as I'm looking at it, this is about right. So at 0, I'm going to put it at about 1. And at 3 pi over 2, or excuse me, at pi, I'm going to put it at -1. And here's my 0 term. Again, it comes back up to about 1. So I want you to notice something. This is what it's going to do. And that is identical to cosine. So maybe you don't count that as a proof, but you can do it by inspection to say that the derivative of sine is cosine. Just that easy. And now let's try it for cosine. This counts as a demonstration by inspection, I think they call it. It doesn't matter. If you can learn what it is, that's what matters. So let's look at cosine. Well, what's the derivative right here is 0. Right, so I'll put it at 0. And we'll use a different color again. Let me get my hashes in here for just one time around the circle. How about we use pink? Pink shows up pretty good, I think. It does. Okay. So cosine, the derivative is 0 here, so I'm going to start at 0. And here I'm going to call it about -1. It's about a 45-degree angle. If I was a better artist, it would be even better. I'll put it about there, -1 and +1. Why not? And maybe even just for consistency, I'll put 1 and -1 on that guy too. Okay. What about here? Well, it's 0 again. It's flat. So my derivative is 0. I want to keep in mind this is ddh of cosine of h. In other words, the derivative with respect to the angle, not a variable h or x, y, z or anything else. It's the angle we're taking derivatives for. And this one is +1, and this one here is 0 again. So it becomes +1 and 0. So if you notice, something's different here because you might have thought it was going to be sine. But sine is this. It's exactly opposite. In fact, we find, if you do a lot of algebra and you get really smart, that the derivative of cosine is negative sine. And that is all you need to understand here, is how you can draw these out, and then you can use them to demonstrate to yourself what the derivatives are. But if you really want to just learn the rules, here's how you do it. The derivative, and I'm going to use theta to keep in mind that it's an angle. We've learned by inspection that the derivative of sine is cosine. And we've learned by inspection that if we want to take another derivative, and this time of cosine, it becomes negative sine. Why does this matter? Because I can keep going, right? The derivative of negative sine becomes negative cosine. And guess what that becomes? Positive sine. And then you end up back at the top. So you have a loop that goes infinitum. It shifts and shifts and shifts. But you can also say, if you're looking at this, that if I want to take, and they always write this funny. I think they write it like this. Like they write it as like d2 d theta squared. I never get it right. The second derivative, I would write it as like f double prime of sine of theta equals negative sine of theta. So if you take two derivatives of just sine, you're going to end up with just a negative value. If I take the fourth derivative of sine, or of any trig between sine and cosine anyway, I'm going to end up with himself or herself again. How bizarre is that? So as we're working through sine and cosine functions, the number of derivatives you can take is infinity. And it'll always just kind of shift the wave or flip the wave, move the wave around. You can think of it a lot of different ways. This is just the easiest way by inspection that I prove to myself this is true. The algebra isn't that bad, but this is easier. Draw out what sine and cosine are. Just start by looking at the unit circle and look at the y values and the x values, and just map it out for yourself every few degrees here, every 45 degrees, every 90 degrees, whatever you need, and guesstimate it, and you will see what the derivative is, and then compare it to the originals if you need clarification. But the easiest thing to remember is that it goes sine, cosine, negative cosine, and then you're back to sine. So that's all you need to know to do the next problem set, which is what we should go into now.